6/9 now. Didn't make any mistakes there, did we? Hey, welcome again. We love to have you folks here on T and Learn Mathline. Here in the summer afternoons, it's so good to see you and so good for you to see me. I hope you're out there tuned in to watch this great show. I'm Ernie Roberts. I'm your host of T and Learn Mathline Summer School. Now, what have we got going on today? Well, we've been remediating, we have been reviewing, we have been getting you ready for the upcoming school year. No matter when it starts, whether it be August, September for you, we're getting you ready and set to go and be stellar students of math in your math classes come in the fall. But you know what? Sit back, get you some pencil, get some paper. The lessons aren't that hard. We try to pick a little bit of a topic at a time and work them out, work through them, and a lot of examples, a lot of problems, and hopefully get you better. All right, that's the idea. That's the idea. So let's see what's going to happen today. What is our topic for today, guys? What have we got going here? An improper mixing. You know, that sounds like to me that we're going to be doing with fractions, mixed fractions, and also improper here on T and Learn Mathline Summer School. Again, we're glad that you've tuned in today. Now, it's not a call-in day, as you probably well know. It's summertime, and we're off in some respects. But what you can do, you can still send us questions. You can still send us problems that you want to see worked out, and do that based Facebook, email, texting, however you can get to us. We will be glad to take care of you on that, all right? So you do that for us, and we will address it in a later show. But today, it's all about improper fractions and mixed fractions and how they relate to each other. So let's see our first problem and see where we're going to go on this. Okay, guys? Thank you. Here we go. It says we're going to change 10/3 to a mixed fraction. All right? Now, first of all, just a couple of definitions of what we've got going on this show. The 10/3, or sometimes we love to affectionately call this 10/3, it's an improper fraction because the numerator is bigger than the denominator. Now, where do we use mixed fractions? Usually when we're trying to add or subtract, and also they're good to help us when we're trying to see order on a number line. Which one is less, greater, or perhaps even equal, all right, is to get into a mixed fraction mode. Much easier to add 3.5 than 7/2, all right? 3.5 versus 7/2. A lot easier to work with that, and it makes more sense to me, all right? So in this case, we've got 10/3, which also means, by the way, when I use that over, means divided by, because that's what fractions are all about. So when we see this, it's 10 divided by 3, or if we see it in this nice vertical fashion, which I tend to like better, it simply means division. It's division, and that, folks, is how we're going to take this thing into a mixed fraction. We're going to need to divide and keep a remainder. That's the deal. And that's why you pick up fractions a little bit more so after you've learned how to, guess what, add, subtract, multiply, and divide with whole numbers, all right? So let's take a look at this. 3 divided into 10. I'm going to just do it right off out here to the side. There we go. 3 divided into 10. And what you see is simple. It's just short division. It really is. I'm not going to call it long division because it's really going to be very short. But we're going to take our 3 and divide it into 10, all right? That's where we start. 3 goes in there. It goes 3 times, all right? And by that estimation, remember we do a quick multiplication here. These numbers aren't very difficult, are they? You like that? I do too. We're going to say 3 times 3, which gives us that 9, and we have 1 left over. Now, where does the 1 go? It's the remainder. And we start out with this 10/3. I'm going to rewrite it right down here. And what we want to do with that is to say it goes 3 times, and we're going to build a fraction with the remainder. Now, the question is, does the remainder go over the 3, or does it go over the 10? Well, the remainder is going to go in the top. And since we're building a fraction out of this fraction, we need to keep the denominator the same. So there we go. We've got 3 1/3, and that's your story, all right? Now, again, it's not 3 1/10. It's going to be 3 1/3. And if you were to plug that on the calculator, good old 10 divided by 3, guess what? You'd see 3.33333333. Well, guess what? 0.333333 and keeps going on and on. That's equal to 1/3. That's equal to 1/3. And that's where we are here as we change to mixed numbers. Now, can you do that division in your head? Probably so. I would say most of you can. I wanted to show you exactly where it's coming from. But remember, and so many times we tend to forget this. Even as teachers, I forget to emphasize this a lot of times. But this is just division. A fraction is a way of writing a division. The numerator divided by the denominator, and it works out beautifully. That's how you get to a mixed number. So that's our story today. We're going to do some practice with these. Let's practice a few here in just a second. And we're going to go in reverse. You know me, I like to go things back and forth, back and forth. So we're going to do just that. But let's take a look at another problem here, all right? It says change 27 divided by 12, 27 twelfths, or 27 over 12. We hear all of those meaning basically the same thing to our ears. I'm going to rewrite it down here so we can really see this is a nice division that's going to go on. Two options. Some of you say, I got it. You're going to divide 12 right into 27. That's a good way to go, yes. So off to the side here, we're going to do a quick 12 into 27. Goes more than once, doesn't it? It goes twice. So we'll put a 2 up there. 2 times 12 is going to give me 24, and I have 3 left over. Now, when I put that 3 up here, remember, it's over 12. It's over what we divided by. That's what the remainder goes by. 3 over 12 is not reduced. So we want to reduce that down. That's going to give us 2 and 1/4. Because we're going to divide 3 into 3 goes 1. 3 into 12 goes 4. So there you go, 2 and 1/4. Now, I know some of you who are watching this afternoon are about to say, Ernie, could we have reduced 27 over 12 and then done the division and done it in our head? Actually, you could have done this in your head too, probably. But this required a little bit more movement. Okay, well, let's try it. I like that idea. My goodness, if we can reduce here, that means we probably could reduce over here. Actually, it means we would be able to. So let's see. Divide by 3. Divide by 3. It's just like dividing by 1 there. The 3 over 3. We've been watching the series lately. You understand that's a big deal, all right, when we work for this reducing and when we inflate it sometimes. And let's see. We've got 9 over 4. And you know what? 4 goes into 9 2 times. You got 1 left over. That will give you 2 and 1/4 just as well. So a couple of ways you can go after it. Sometimes we don't remember to look for reducing at the beginning, but I think that's a wise thing to do. I really do. I would much rather go through this from the division standpoint. It's a lot easier. It's a lot easier than dividing by 12, and especially if that number gets really big, then it can be a little more nerve-wracking. So there you go. It's not a hard lesson today, is it? This is good review for you. I hope everybody can handle it. Make 100 on this quiz if we go through each problem together. Let's take a look at our next problem here. 32 over 5, or 32 fifths. That means a lot of stuff going on here. Let's write it as a fraction. Big one there. And again, the storyline is we're going to divide 5 into 32. Let's try doing this one mental math. First of all, remember what I gave a minute ago? Oh boy, stutter, Ernie. What was the hint I gave? Could we reduce? Well, 32 and 5 doesn't help us any, all right? We don't have anything that will divide into both those evenly, except 1, and again, that doesn't help us much. So we're going to divide the 5 into 32. Unfortunately, it does not go an even number of times, but we know our times tables. We know we can't go over 32. We've got to go under a little bit. That's going to go in there 6 times. Now take a look at this. 6 times that 5. That's what we're worrying about. What's 6 times 5? It's going to be 30. And I'll subtract the 32 minus 30. All right, in other words, I'm going to take 32 minus 30. I'll subtract the 30 from the 32. It's a mouthful. And I've got 2 left over. And what am I going to do with that? I'm going to make that my numerator of my mixed fraction part and put the 5 right back in the denominator where it was originally. So again, divide it, you get the 6. Multiply times the 5, you get 30. Subtract it from your 32. And what's left over is your numerator. What you had to begin with as a denominator stays there. 32 doesn't come back into the problem at all. It's got a whole different look, okay? And that's your final answer. So pretty easy, pretty quick, and very painless. Again, when do we do these? Usually if we're have a mixed number situation, or we've got a very improper looking fraction at the end, we like to make it go down to a mixed number. If you start with mixed numbers, end with mixed numbers. If you start with fractions, you can go either way. You can go either way. Sometimes it pays to be mixed. Sometimes it's going to come out very nice, just a simple fraction, all right? But let's look at a couple more here. Give a little more practice, as we say here. And we're going to look at 40 divided by 15, or 40 over 15. Ooh. And again, this is one of those, numbers are starting to get a little bigger, aren't they, in the denominator? And that makes us a little bit nervous and antsy at times. I know. I do too. But notice we've got a 0 and a 5 staring at us in these numbers, 40 and 15. Both of these numbers are multiples of 5. That means 5 will divide into both of these evenly. Let's make this work for us in a much easier fashion. Let's reduce this fraction to begin with. And I mean by dividing by 5 on both cases, because, man, all of a sudden these numbers just really melt down quite nicely. We've got 8 in the numerator. We've got 3 in the denominator. That's easy to work with. How many times will 3 go into 8? Well, it'll go 2 times. All right, so let's play this out. It's going to go 2 times. Mental math time, right? 2 times 3 gets you 6. You've got 2 left over. That 2 goes right in there. And bring the 3, the denominator, right back into the denominator position for the ride. 2 2/3 from 8/3. 8/3 or 8 over 3. Or as I remember, as we said, 8 divided by 3. Those are your numbers. That's different ways to read that 8/3 there. But does break down into a nice mixed number, mixed fraction of 2 2/3. You got it going? Everybody good out there? Let's do another one. We're just going to practice a little bit here. Whoo-wee! Told you we're going to make the numbers bigger. Here we go. 35. My goodness, over 28. This one you have to stare at a minute. And I'm going like, and you're going like, wow, what can we do there? Well, we could go ahead and divide. 28 goes into 35. It'll go 1 time. And it looks like you're going to have 7 left over. And that's 7 over 28. Now, I noticed something. 7 will divide into both 28 and 7, and that comes up actually pretty nice. Actually, very nice. 1 1/4. All right, 1 1/4. Now, why did I go there, you say, Ernie? Why did you do that? Well, because 35 and 28, sometimes I have students and sometimes I look at that and I'm going like, well, it doesn't look like 2 goes in there, it doesn't look like 3 goes in there, and 4 or nothing, and 5 only goes in 1. I mean, go on and on up the ladder and you're going like, I kind of given up. What number divides into both of them? Now, if you know your times tables, that one was a quick one. You also notice there was a 7-unit difference between them. That kind of gave me a hint, 7 might be a good answer. But let's go back to 35 divided by 28. And let's divide both of these numbers by 7. That's the number that is common as a GCF, or a greatest common factor, that will divide into both those evenly. And again, that leaves us with 5 divided by 4, 5/4. And guess what? Yes, sirree. Divide that, go in there. Let's try that again. Divide that in there. We have 1 time. Have 1 left over. Put it over 4. You got the same value either way. Again, if you spot the 7, I would definitely recommend it on this one. Go ahead and reduce that down by 7. So much easier to look at 5/4, all right? Here, you can still get out of it. You can still get out of it. And the 7 over 28 will give you an aha moment. Oh, there's a 7. Of course, 7 divides into both of those and gives us 1/4 also. So you got 2 options, 2 ways to work a problem. Sometimes it works that way. Sometimes you just don't have anything to reduce, so you just got to go smack into it and work it out. Do the long division, do the short division, however you want to look at that. Now, we've been going one way. We've been coming from improper to mixed numbers, or mixed fractions. Let's go the other way. Let's start with the mixed fraction and see how we're going to go and make an improper fraction happen, all right? So here we go. The first problem says, write 3, and by the way, that's supposed to be a 3 3/4, so I'm going to just jam them together a little bit better. Tell you, when you try to write a printout there, you want to make sure everybody understands that's separated from the fraction, but they are a mixed fraction together. That's not multiplication, that's just 3 3/4. as an improper fraction. So in other words, what we want to end up with is the numerator larger than the denominator, but it's got to be the same value. It's got to be the same expression. So in other words, if we were to reverse that process, whatever we get over here, we should be able to get back to 3 3/4. Now, some of you out there are already going like, I know what to do, I know what to do. And let's do it, all right? First of all, think about how we got there by division. So this means we've got to do a little multiplication and addition. The way we got to the mixed number, we divided and then we had a remainder left over, right? That we got by subtracting. So we're going to reverse the process. We're going to reverse the process. We're going to go and say the big 3 times 4, all right? Big 3 times 4, which gives us 12. Keep that in your mind. Keep that on your head. And then we're going to add the 3. We're going to add the 3. So sounds to me like we're going to take, and by the way, we're going to keep the 4. Remember, we never change that denominator. The denominator stays the same. The question is, what's going in the numerator? What's going to go in the numerator? So we're going to take 3 times 4. There you go. Everybody watch. 3 times 4 gives you 12. Then add that little number on top, and that's going to give us 15. We say, well, Ernie, that took no time at all. Exactly. It takes no time at all to do an improper fraction if you're making that. Now remember, you say, when do you use that? You're going to use that when you multiply mixed numbers together and when you divide, all right? You need it there. Now you really don't need improper fractions to add and subtract. I've had some people tell me, well, why don't you teach that way? I'm going, that's huge numbers. You don't really need those. All you need to worry about is what's going on with the fractions, and you can either add or subtract as needed on the mixed numbers when you're doing on the big number part, the integer part, we'll call it. You always, those are the deals that you worry about at the end, all right? So in this case, like I said, multiplying and dividing, that's where you go. That's where you go. Now, does it revert back to 3 3/4? Well, I bet it does. Let's see. If we take that 15 divided by 4 and we go 3 times, remember 3 times 4 gives you, 12. Subtract that 12 from the 15. Guess what? You got 3 left over. So that's the beauty of this. You can go to the improper or you can go back to the mixed. And you can always check yourself to make sure you didn't make any careless mistakes, right? And that's a good thing to do. It's a good thing to always do. So recheck your work, and that works nicely. Doesn't take much time, does it? Let's do another practice here. All right, let's see what we got. 7 2/5. 7 2/5. We're going to fly through this one, right? Everybody's good at this. We're going to take our 7 times 5. By the way, it does help to know those multiplication facts, doesn't it? 7 times 5 we know is 35. Add that 2 to it. We're going to get 37. Boy, that was quick. Can we do a mental check? Let's do it mental. 5 goes back into 37. It goes, wow, 7 times. 7 times 5, 35. Got 2 left over. Bang, we are back where we started from. So that's an easy, easy transition to make, going from improper to, let me try it again. Improper, here, back to mixed. You can also go mixed to improper, both ways. It gets easier and easier as you do more and more of them, right? There you go. Now, let's look at a couple more. 3 11/12. Got it right here. A couple more practice moments. And then we're going to try to see what we know. Find out what we know here. 3 11/12. A little bit more arithmetic going on here, but you know your 12's time facts, right? You know those multiplication facts up through 12. 3 times 12 is going to get us 36. And we have 11 to add to that 36. That should give us 47 divided by 36. Or 47/36 if you want to get down to it. Now, what does this tell me? If I reverse the process, do I want to have a 36 down there? Hey, just a minute. Let's go just a second here. Did we get carried away with that 36? I believe we did. Let's go back. Let's go back. This is a common mistake, and I want you to see this. Yes, he did it on purpose, all right? So let's do this again. Don't change the denominator, all right? So let's go back through this. 3 times 12 is 36. That's great. But we keep the 12, folks. We keep the 12. So many times we get different numbers going in your head, it's easy to put the wrong thing down. But we don't want to do that. That would be one of those things in the textbook they said, so-and-so did this. Can you figure out their error? Yes, there it would be. It's not 3 times 12 gives us 36 right here. It's 3 times 12 gives us 36 plus 11. The 47 goes over the 12. And by the way, if you were working backwards to check, you would have caught that little error there and said, oops, I need to go back and fix that, don't I? So again, check it now. 12 goes into 47. How many times? Goes 3 times. 36. Subtract 36 from 47 in your head. You're back at 3 and 11 twelfths. So be careful. Be ye careful. Like I said, it's an easy thing, but it's also easy to make a careless mistake. What happens if we need to reduce? Let's check one more here. We've got 5 and 6/8. You got 5 and 6/8. Before you make it as an improper fraction, you could go with what you've got here. Again, that's the beauty of this. But I noticed that 6/8 will reduce, and it will bring itself down to 5 and 3/4. Now, that's not the final answer. We're trying to go where? We want to become improper, all right? So let's see how that would work. Oh, very easily, right? It's going to be, remember, keep that 4 right there. And we go 5 times 4, which will give you 20. Add 3. You got 23. Does it work back in reverse? Well, it certainly does. And you know 3/4 will go back to 6/8. Now I want to check it. I want to check out if we take 5 and 6/8 again, but this time we go with 46 divided by 8. Will we come up with 23 divided by 4? Well, when we divide both of these by 2, notice they're even. But boy, it's a lot nicer to pick that up earlier, isn't it? That would give us what? The 23. And there's the 4. And again, you come out to the same value. So again, that reducing element, it's there to help you. It's not to drive you crazy. It's not to make you freak out. It's there to make the numbers smaller, and they're so much easier to work through, right? You can definitely tell me that. Now, question marks, just to see how good we're doing here on this, and we're going to hit these. Let's take a look at this next question I've got for you. Is the fraction 35 ninths the same as 4 and 1/9? So here we go. A couple of ways we can do it, right? It's an open question, pretty straightforward. The question is, are these the same? Are they same naming of a quantity? I could divide 9 into 35 and see how many times it goes. All right, I could do that. And I believe 9 is going to go in there only 3 times. That already tells me something's off and messy, but let's go ahead and finish it off. 3 times 9 is 27. Subtracted from 35, you're going to have 8/9. Well, obviously they aren't the same. All right. Another option, keep the 35 over 9, and let's see what this does when we make it improper. Take 4 times 9, add 1. You got 37 over 9. So obviously, they are not equal. They're not the same. So the big answer, no. No on this one. But that's how you've got 2 options now. You got 2 ways to answer that question and be accurate and be correct. All right? How good is that? 2 ways to work out, and we've got it. Let's take one more look at a problem here, and let's see what we have here. We've got the fraction 20 divided by 6, and we got 3 1/3 that we want to compare it to. So we got 3 1/3. We've got 20 over 6. What I would do, you better believe it, I would divide this by 2 right off the bat, which is going to give us 10 over 3. Does that sound familiar? It was our first problem on the show, wasn't it? Which gives us 3 1/3. And you could also go back over here and say, hey, 3 times 3 is 9. Add 1 to that. We're back to 10 over 3. And could you get back to 20 over 6? Certainly. Multiply the numerator by 2. Do your denominator by 2. And dear friends, we have 20 over 6. And yes, they are. This one is a big yes. So 20 over 6 does equal, oops, ran out of room there, 3 1/3. That's your story. That's your story. All right. And again, reduce when you can. That's my advice to you also. And be careful. Keep the denominators the same when you make those transitions. Keep those denominators the same. And you know what? Hey, we've had another great day here on T and Learn Mathline. It's summer school time. At the beginning of the show, we always tell you to send us questions, send us comments. We like to know that you're watching us. Like us on Facebook. We love it when you like us there. We say that many, many times. But you know what? That's how we communicate with you, especially in the summertime when you can't call in. Now, come August, we will be back here for a 4th season. We will be live shows again, having a great time, keeping you guys hopefully excited about math and also being able to help you out whenever you might need a little push, a little shove. And we love it when you communicate with us. So hope everybody's having a great summer out there. Again, keep in touch with us. We're not going away. We're going to be around summer school all the way through July. But we love to hear from you. Still keep in contact with us. And you know what? Again, I said we'll be back in the fall. Great times coming your way again. And again, thank you for being with us today. We hope you've enjoyed it. And we will see you next time again.